Before we begin talking about Milankovitch cycles, we first need to deal with, talk about what causes our seasons in the first place. And so one of the common misconceptions that I hear even adults say is the reason that we have seasons is because our Earth is because of the Earth's orbit being closer and further away from the sun. And so their logic would follow that this particular Earth, as we travel around our orbit annually, that when we are very close to the sun, then that would be considered our summer. And whenever we're very far away from the sun, that would be considered our winter. And again, I said this is a misconception. This is not what causes our seasons, but let's talk about where this misconception actually came from and why we actually, why it's so pervasive, and this is, and why people think that this is true. So I'm going to draw in an orbital path as best as I can. Part of the logic that follows this is that, is our Earth's orbit an exact a circular path? And so that particular logic is actually not really all that flawed. We have what's called an eccentric orbit. And so eccentricity is actually just a ratio for ellipses. So here's an ellipse, and what the ratio would be is the short edge to the long diameter. The short diameter to that long diameter is what eccentricity is calculated by. So this particular oval would have a very high eccentricity, whereas anything that has like a very nearly circular path would have a very low eccentricity. And so as we look at eccentricity, this particular, this top ellipse right here, that top ellipse has a very high eccentricity, and this very circular path has a very low eccentricity. And the truth about our orbital path is we are very nearly a perfect circle. I mean, it's almost exactly a perfectly perfect circle. However, to say that it is a perfect circle is not true. So we are slightly eccentric in our orbital path. So I'm going to try and draw in our orbital path as best as I can. You guys will kind of have to just bear with me for just a moment to kind of get this. And we'll get these other circles out of the way. So I drew our orbital path slightly exaggerated because, again, like I said, it is very nearly a perfect circle. And the misconception is that whenever we are very close to the sun, in this particular drawing, you would call this perihelion. And whenever the sun is over on this side of our orbital path, we would call this aphelion. And so our Earth has these paths, and the one major piece that refutes this logic is that if we are using the perspective of the northern hemisphere, the truth of this is when we're at perihelion, or when we're closest to the sun, is actually winter for the northern hemisphere. And when we're farthest away, this is actually our summer for the northern hemisphere. So that's the easiest way to decide, okay, that theory of being close and far away from the sun is a flawed logic. And so as we look at this, and we look at our perihelion and aphelion locations, we need to think about what really does cause seasons on Earth. So that'll be what we talk about next.